if you're finding it hard to imagine, it's going to be hard to imagine for many of us because we don't see an object that is always in motion, right? We have always seen an object that comes to rest because there is a lot of resistance in the air and in our surroundings, right? So I would recommend this movie called Gravity. I think it's on Amazon Prime or on Netflix. You should watch that movie and where where it is picturized very very clearly on what happens in the space when there is when basically you can experience Newton's first law that an object that continues to move will always continue, will keep moving, right? I mean, and that is picturized very very well. And you should really watch that movie. So the Newton's first law, we just went through the Newton's first law, which is like unless there is an external intervention, an object will continue to maintain its natural state, which is it either stays in motion with a constant velocity or it stays at rest, right? And we also went through the idea of why it is called the law of inertia, because that the natural state can be disturbed only through an external intervention in the form of a push or a pull, and that external intervention alters the inertia, and which means that it changes the velocity of that object changes. So that in a way defines inertia as well. That inertia is an object's resistance to any change in velocity. So now that we have gone through the first law, so I think it will be a good time to connect the first law with an example that we went through in our earlier video of motion. In the earlier chapter, we went through this example of Galileo stating this fact that it's going to be hard to perceive motion, right? And the example, if you recall, he called out the example of a moving ship on an ocean that is calm, wherein somebody who is in the deck, somebody who's sleeping in the deck and who doesn't have any doors or windows to see the ocean, he or she will not know whether the ship is actually moving or is actually staying at one point. Right, and the whole reason is that the whole reason why it is hard for that person to perceive motion is because the inertia of the ship and the object, his deck and his bed, is all is undisturbed, because everything is either moving or it is at the same spot, right? So the inertia is not disturbed. So that is why it is hard to perceive motion. So whenever inertia is not altered or disturbed, perceiving motion is hard. It's not going to be possible, right? So that's the crux. So given that now that we have covered the natural state of an object, now let's compare the two objects. One that is actually one that is actually at rest, and another object that is actually moving, right? Let's consider object A, which is at rest, and object B, which is possibly moving with a certain velocity v, right? Now we saw that both are natural states, right? This one will continue to be at rest, and this one will continue to move with that motion unless there is no resistance in the medium, right? Now think about this, right? Though these two are natural states, valid natural states of any object, there must be some difference. There must be some property that this one has, which probably this one doesn't have, right? Because this one is already moving, and you see that think for a moment that this is a bus, right? This is a bus that is stationed in a bus stop, and this is a bus that is moving, right? Which is a safer spot for you? You're going to feel safe when you're standing next to a bus that is stationed, but you would obviously stay away from the bus that is moving because it will hit you and hurt you, right? So which means that something that is in motion has some property which an object that is at rest doesn't have, right? And what is that property? So the property that a property that moving objects have is what is termed as momentum, and momentum is defined as the mass of that particular object times the velocity of that particular object. So that is a property uh, which differentiates a moving object from an object that is at rest, or to it compares the two objects that are moving as well. So momentum is the most fundamental property that defines that defines an object that defines the behavior of an object. So momentum, and I think there is a bit of a latency here. Let me quickly sync this. Okay. So yeah. So momentum is a property, and the most fundamental property, and we refer to momentum by the letter P. Right. So this is the momentum is defined. Now, so we saw that an external action, an external intervention can alter the inertia, and thus it will alter the velocity of an object, and then it can set either an object that is at rest into motion, or it can set an object that is already in motion come to rest, or change its velocity. Now, how exactly does that external intervention causes that change in velocity? Let's delve a little deeper into that. So when we say an object, when we say an object that is when we say an external intervention is causing a change in state for a particular object. Let's consider this object to be at rest for now, right? It doesn't matter whether it is at rest or if it is at motion, but let's understand what is happening when that external intervention happens in the form of a push or a pull. Now, when that when we really push or pull, we learned that this alters the inertia, right? It alters the inertia of that object. Thus, the velocity of that object changes, right? It either increases from zero, or if it is already moving, it changes, right? So, and it does that change, that external intervention alters that inertia by exerting an influence on this particular object, and that influence is called force. So, force is the influence. Exerted by that external intervention in the form of a push or a pull. When I'm pushing something, I'm applying a force, right? So, force is that influence that is applied on that particular body, and it is the force that alters the inertia, and then the object's velocity changes, right? So how do we quantify force, right? How do we quantify force? Let's say that okay, I have pushed something, and I see that the object's behavior has changed, which means it started to move. Let's say that the object was already at rest and it started to move. Now, how do we quantify, the amount of influence that I've left on that particular object? Now, we know that, and let's call force by the letter F, right? So, let's try to quantify the force here. Now, let's do a small thought experiment. Let's take this object which is moving with a certain velocity v. Okay. And you have pushed it for 1 second. You have applied some force for, say, 1 second, right? And what will happen if you apply that force for 1 second? Obviously, that the velocity of that object will change, right? Let's call it v prime, right? Now, what will happen if I change the now that you have just applied it for 1 second, which means that you have taken your hand off, right, from that object. Now that the object will continue to be in its natural state, which is to keep moving in this particular velocity. Now, which means that what will happen when you once again apply a force of the same amount of force on that particular object for the same 1 second, what will happen? The object's velocity, which was v prime, will become v double prime, right? It will increase further, right? After applying another dose of influence on that particular object. Now, what has happened to that object is, you have the object's original momentum, right? Before applying the force, the momentum of this object must have been mv. Let's consider m to be the mass of this particular object. Now, after applying this force, it would have become mv prime. And after applying the second amount of force, we know that it would have become mv double prime, right? Now, the momentum of the object has changed from mv to mv dash to mv double dash. Now, let's say that what will happen if you had applied the force together, right? Instead of applying it in two doses, let's say that here you have given a push for 1 second, and here you have given a push for another 1 second. Let's say that if you had continuously pushed this object for 2 seconds, what would have happened? The object that was originally moving with a velocity of v would now start moving with a velocity of v double prime, which means that its momentum would have directly changed from mv to mv double prime. Right? So in a way, what you can learn here is that the force is actually proportional to the change in the rate of change of momentum, right? Because when you're changing it by 1 second, the momentum changes to mv prime, and when you give another dose for 1 second, it changes from mv prime to mv double prime, right? So force is directly proportional to the change in rate of change in momentum, right? When you apply the force together, when you apply the force together, which means that the object's momentum has directly shifted from mv to mv prime. And because you have given the same amount of force, which means that there is the rate at which the momentum has changed will be proportional to what you have applied, right? So we are calling del P as the change in the momentum for the time that is applied, right? So let's say that you have applied for t seconds, you have given the same amount of push for t seconds. What we can observe is the change in momentum from the initial momentum to the final momentum, right? Divided by the overall time. So what is that change in momentum? So it is going to be, the change in momentum is going to be mv prime minus mv divided by t, and which means that f is directly proportional to m into v prime double prime minus v over t. And we know that we know what this is, right? So this is the change in velocity of that particular object over time, which means that this is the acceleration experienced by this particular object after after being on the influence of this force. So we can replace this by a, and which means that f is directly proportional to ma, right? Now, this is the second law as postulated by.
One final thing before you leave. If you wish to revise the concepts that you've just learned, please look up and try out the free Revise app bot on Telegram app. Telegram is available for free on both iPhone and Android. Also, if you did like the content that you just watched, please do like, share and subscribe this with your friends. Thank you.